Hello and welcome back to Year 7s. We're going to continue solving equations, and if you look at the equation, what makes this one different from all the other ones we've solved before? Hopefully you recognize that this time we have x's on both sides of the equal sign. So continuing with our theme of solving algebra equations by getting x all by itself on one side equals a number on the other side, we're going to continue that. This time we need to get all our x's onto one side. So we have a choice, move them all onto the left or all onto the right. So let's look at what happens if we try different ways. What if I add 10 first to both sides? That will leave me with 4x equals 2x plus 28. So all my numbers are on the right side, and now I want to move my x's, so I'm going to get rid of this 2x. I'm going to move the 2x to the left side by subtracting 2x from both sides. So 2x equals 28, and then of course we're going to divide by 2. So x equals 14, and again we can check that this answer is right. 4 times 14 minus 10, does that equal 2 times 14 plus 18? 4 times 14, if I double it to get 28 and double it, I get 56 minus 10 is 46. Does that equal 2 times 14 is 28, plus 18 is 46. So the answer to the question is yes, they are the same, which means our answer is correct. So that time we started by moving the 10. What if we start with something else? For example, what if I decide to move this 2x first and take away 2x from both sides? On the left side, 4x minus 2x is 2x minus 10. On the right side, 2x minus 2x is 0. And I'm just left with 18. So now I have my x's all together, which is what we want. So we need to get the 10 onto the other side by adding 10 to both sides. 2x equals 28. And then we divide both sides by 2. And we get x equals 14, which is the same answer we had before. So that's a different way to do it. So last time we moved the 2x over to the left side to get all the x's on the left. What if we want to do it the other way? What if we want the x's on the right side? Let's see what happens. So if I want the x's on the right side, I'm going to take away 4x from the left, take away 4x from the right. That leaves me with minus 10 on the left. On the right, 2x minus 4x is minus 2x plus 18. So my x's are on the right. That means I need the numbers on the left. I need to move the 18. So on the left, I have minus 28. On the right, I have minus 2x. And then, of course, we just want x, so I'm going to divide by negative 2. And if we do that, we're left with 14 equals x, which is the same answer we got before. Now, what do you notice is different about this one than when I move the 2x to the other side? The difference is this side, well, we get the same answer, and it's about the same number of steps. I have a lot more negatives this way. So the very simple rule, when you have x's on both sides and you're trying to decide which side should I move them to, there's one simple rule I like to remember, and that is simply move the smaller one. In this case, I have a 2x on the right and a 4x on the left, so I'm going to move the smaller one. Again, it doesn't matter technically, but by moving the smaller one, you reduce the number of negatives that you might have to deal with. Okay, I want you to pause the video. I want you to solve this, and when you're done, start the video and see how you've done. Okay, so what are we going to move? On the right side, we have a minus 3x. On the left side, we have a positive 7x. So the smaller one is the 3x, so I'm going to add 3x to both sides. Again, you can do it the other way, but as you'll see, this way is a little bit tidier. So on the left, I have 10x plus 9. On the right, I have 35 because minus 3x plus 3x is 0. So my x's are together. I need to move the 9's. So 10x equals 26, and I need to divide by 10, and x equals 2.6. In this case, you can leave it as a fraction. You could simplify it to 13 over 5, or you could leave it as 2.6. Okay, I'll do another example here. This time we've got 8x on the left and 3x on the right. So which one of these is smaller? Is 3x or 8x smaller? Well, obviously 3x is smaller. we will move that first. So I'm going to move 3x from both sides. On the left, I have 5x plus 17. On the right, I just have minus 13. So my x's are all on the left. I want my numbers on the right. So I'm going to take away 17. And if I do that, I get 5x equals minus 30. And then I want 1x. So I'm going to divide by 5. And my final answer is going to be x equals minus 6. And again, we can stick that in and check it. Okay, I want you to do this one on your own. Pause the video, go ahead and solve this, and then restart the video and see how you did. Okay, we're trying to decide which one to move. I have a 4x and a 9x. Obviously, the 4x is smaller, so I'm going to subtract 4x from both sides. That leaves me on the left side with 5x minus 20. On the right side, 4x minus 4x is 0, just leaves me with minus 70. Now, the x's are on the left, so I need to get all the numbers on the right. So 5x equals minus 50. And then our last step, we want 1x, so I'm going to divide by 5 both sides, and x equals minus 10. Okay, your turn to solve some more. Go ahead, pause the video, solve these in your book. Nice, clear working out step by step, and then we will see how you did. Okay, let's see how we did. For the first one, I have 5x and 9x, so I'm going to move the 5x, take away 5x from both sides. 4x plus 4 equals 34. Take away 4 from both sides, 4x equals 30. X equals 30 over 4, which equals 15 over 2. You can leave it like that or change it to 7.5, but you can leave it as a simplified improper fraction. The next one, we have 3x and 8x. 3x is smaller, so I'm going to subtract 3x from both sides. 56 equals 5x minus 22. I'm going to add 22 to both sides, so I get 78 equals 5x. Divide by 5, x equals 78 over 5, which, although it looks very messy, that is a simplified improper fraction. It's okay in algebra to leave our answer like that. If you do want to simplify it, the answer is going to be 5 times 15 is 75, so it's going to be 15 and 3/5, but it is all right to leave it as an improper fraction. The next one, I have 2x and 5x, so I'm going to move the 2x. So 5 is going to equal 3x plus 38. Then I'm going to move the 38, so I'm going to have minus 35 equals 3x. And then divide both sides by 3, x equals minus 35 over 3, and we can leave the answer like that. Or if you do insist on simplifying it, right, that would be 11, because 3 times 11 is 33. That would be minus 11 and 2/3. All right, the next one. I've got a 6x and a minus 3x. So I want to move the minus 3x. I want to add 3x to both sides. So on the left, I'm going to have 9x minus 37 equals 8. I'm going to add 37 to both sides. 9x equals 45. Divide by 9, x equals 5. Okay, the last one of this batch, I have a minus 2x and a 7x, so I want to move the minus 2x by adding 2x to both sides. So 9x plus 85 equals 13. I'm going to take away 45 from both sides, so 9x equals minus 72, and then I'm going to divide by 9, and x equals minus 8. Again, on all of these, you can check. The checking is a little bit messier this time, but if you have time and if you have a calculator, I would definitely recommend checking your answers. All right, last set of problems. Pause the video, solve these in your book, and then restart the video, and we'll see how you did. Okay, the first one, I have a minus 4x and a positive 4x. The minus 4x is smaller. That's what I'm going to move. Add 4x to both sides. On the right side, I have 8x minus 19. I'm going to add 19 to both sides. So I get 56 equals 8x. divided by 8, x equals 7. The next one, I have an 8y and an 11y, so I'm going to move the 8y, subtract 8y from both sides. So on the left, I have 3y plus 15 equals minus 19 on the right. I'm going to subtract 15 from both sides. So 3y equals minus 34. And then I'm going to divide by 3. So y equals minus 34 over 3, which cannot be simplified anymore. We can leave our answer that way as an improper fraction. Or if we write it as a mixed number, it would be minus 11 and 1/3. The next one, I have a 9k on the left and an 8k on the right. I want to move that 8k. So I'm going to subtract 8k from both sides. On the left side, I have k minus 14 equals minus 32. I'm going to add 14 to both sides. So k is going to equal minus 18. And that's it, I'm done. 1k is minus 18. The last problem in this set, on the left I have a minus 2y. On the right, I have a 12y. I want to move the minus 2y rather. So I'm going to add 2y to both sides. So on the left, I'm going to have minus 19. If I add 2y to both sides, I get 14y minus 17. I'm going to add 17 to both sides. So I'm going to have minus 2 equals 14y. Divided by 14, y equals minus 2 over 14, which can be simplified to minus 1/7. That is one you do not want to turn into a decimal by hand. If you want to see why, feel free to explore. I will see you next time.